Trig Unit, Section 3, Additional Technical Applications. In this first example, we are to determine the depth of the groove machined in this steel block. If we look at the overall length of this block, it's 3 inches. We know parts of this distance across here, and this is forming a triangle. If we only knew the length of this gap, well, if we put all this information together, subtract what we know from the total distance, it turns out that that span is 0.8 inches. This groove, then when we put this together, is an isosceles triangle. So our next step will be to draw an altitude from the vertex of the groove to the line that we put there to form this triangle. An altitude drawn in an isosceles forms 2 equal right triangles. It bisects the vertex angle, so we have a measure of 41 degrees on our right triangle. It also bisects the opposite side. Our 8/10 gets divided into 2 equal measurements of 4/10. If we enlarge this right triangle that we've just formed, the third, or the vertical side that we're looking for, third piece of information, is the depth. Using the angle as our reference angle, we can label the sides opposite. Don't know about the hypotenuse, but we're interested in the length of the adjacent. Picking the trig ratio that deals with opposite and adjacent, which is tangent. Plugging in the information that we know. Switching d and tangent of 41, we can solve by a division of 4/10 divided by the tangent of 41 and answer the question with a depth of 46/100ths of an inch. This next problem is asking us to determine the total length of steel needed to make this frame. The basic overall shape here is an isosceles triangle, and our job is to figure out the length of all the parts that make this frame. We already know the length of the long horizontal piece, so we're going to have to compute the lengths of the vertical brace in the middle and the 2 remaining sloped sides. We'll call the sloped sides X and the vertical piece Y. So here's our game plan. Find the measure of these missing variables, add them with the given overall length to give us the total length. Our isosceles triangle is already bisected with an altitude, and if we label the sides in this triangle using 35 degrees as our reference angle, we're looking for the opposite, we're also looking for the hypotenuse, and we know the adjacent. You can choose either one of these options using opposite and adjacent to solve for y, or hypotenuse and adjacent to solve for x. We're going to use